Alright, I want to shoot just a sidebar video here about the unit circle. And we're going to learn about the unit circle in section 13.3, and just want to work on that for just a moment. So I grabbed this unit circle off embeddedmath.com. It's a blank one. We're going to fill it out together. If you look on our website there in section 13.3, you'll find an embedded you'll find one of that is one of the documents, the blank one. Go ahead and print that off before we get started, so that if you have to escape out of here and come back to me in just a minute, it'll be great. Alright, so the first thing I want you to do is to draw a line that goes right across here, and that's going to be your x-axis. Okay. And I want you to draw a line that goes right through here, and that's going to be your y-axis. Okay, so I really want you to think of this being the x and y axis that we're all, fairly used to. And so when we think about the points on the x and y axis that we'd be looking at, one of them would be this point right here, 1, 0. And as I moved up to the top of it, I would be at the point 0 on the x and 1 on the y. And as I moved over here to the left, I would be at -1, 0. And down to the bottom, I'd be at 0, -1. So this is a circle with radius 1. Therefore, we call it the unit circle, the 1 unit circle, a circle with radius 1. If I was right here, I would be at 0 degrees. And when we talked about radians and converting things to radians, as we'll talk about in section 13.3, that's 0 radians. The point of radians is, I don't know why, but I always think of this guy, theta guy, walking I don't know if he's much of a walker there, walking around the circle. Radians is a measure around the circle, and degrees is the angle measures that you have. Okay, so if I went all the way around the circle in degrees, that would be 360 degrees. All right, and if I went all the way around the circle in radians, well, we always say what's the circumference of a circle is 2 pi r. So this r happens to be 1, so in radians would be 2 pi all the way around the circle. And if I only went halfway around the circle, that would be 180 degrees, and that would only be 1 pi. And if I went up here to the top, that would be 90 degrees, and that would be called pi over 2, or half pi. And down at the bottom here is 270 degrees, and that's 3 pi over 2. Okay, so that all kind of makes sense. Now, the other thing we talk about is that theta. So let's move just to the first quadrant here, and let's focus on that a little bit. Okay, in our first quadrant, let's switch to red. You'll see 3 lines here. One of them is 30 degrees from center, 30 degrees. One of them is 45 degrees from center. And one of them is 60 degrees. Those are 3 numbers that you need to know and you need to memorize. What you need to know is this quadrant that I'm in is called quadrant 1. And I put an A here because all things are positive in quadrant 1. If I were to convert my degrees to radians, as we'll learn to do today, what you do is you take 30 degrees and you multiply it by pi over 180. And 30 degrees, pi over 180 becomes pi over 6. And 60 times pi over 180 becomes pi over 3. and 45 becomes pi over 4. And that might make sense to you because pi over 2 is right up here, and that's 90, so pi over 4 would be pi over 2 times half. Now, what goes in these brackets here, that's your x and your y, the actual coordinates of these dots out in space. If this guy was walking around and he stopped on those things. The first coordinate would be the cosine of theta. The second coordinate is the sine of theta. So the x number is related to cosine, and the y number is related to sine. So the cosine of 30 degrees is the square root of 3 over 2. And the sine of 30 degrees is 1/2. The cosine of 45 degrees is the square root of 2 over 2. And the sine is the same thing, the square root of 2 over 2. The cosine of 60 degrees is 1/2. And the sine is the square root of 3 over 2. You'll see that that's just flipped around from what we had earlier. Now, here's why those work. Those work because of these special right triangles we have. The 30, 60, 90 that we all learned in geometry class, and the 45, 45, 90 that we all learned in geometry class. Remember, we would call this A, and this would be 2A, and this would be A square roots of 3. This would be A, and A square roots of 2. So if I said find the cosine of 30, well, cosine is adjacent over hypotenuse. So I have A square roots of 3 over 2 times A ends up being the square root of 3 over 2. If I were to find the sine of 30, that's the opposite over the hypotenuse. That's A over 2A ends up being 1/2. And so on and so forth as we work our way through the 45, 45, 90 and the 30, 60, 90. Okay, now as we spread out here across, what I look at is I like to look at this triangle right here. That ends up being my 30, 60, 90 triangle. Now if I take that triangle and I flip it over to this side, 30, 60, 90 triangle again. So the location of these things here end up being in the same exact spot. The square root of 3 over 2 and 1/2. The only difference is over on this side, this was a positive quadrant. But on this side over here, cosine is negative and sine is positive, or x numbers are negative and sine numbers are positive. So that's negative square root of 3 over 2. This one, square root of 2 over 2, square root of 2 over 2. First one's negative. And this one, 1/2, square root of 3 over 2. First one's negative. And you'll see that this is 30 degrees from 180. This is 45. And I always think of them as kind of like a butterfly. They kind of open up from the middle. And I'll try to show that to you in a little bit. So that would make this 150, this 135, and this 120. And in their corresponding thetas and radians, let me see if I can make this make any sense. If this is pi over 6, this would be 2 pi over 6. So 30, 60, 2 pi over 6. And this would be 3 pi over 6, which is pi over 2. That makes this 4 pi over 6, or 2 pi over 3. And it makes 150 5 pi over 6. And it makes 180 6 pi over 6, or just pi. That's how we got that. Now 45 degrees, we had 1 pi over 4, 2 pi over 4, and now we have 3 pi over 4. Okay, let's move on down over here to quadrant 3. Now in quadrant 3, this is 30 degrees from the center line, 45 degrees from the center line, 60 degrees from the center line. And that's what we're always going back to. How far are you from the x-axis? So that would be 210, 225, and 240. Their corresponding angle, this one has a corresponding measure of the square root of 3 over 2, 1/2. This one has corresponding square root of 2 over 2, square root of 2 over 2. And this one has 1/2 square root of 3 over 2. Now there's one thing that we know from algebra class though, is over here this is a negative negative area. The only thing that's positive over here is tangent. So these things all become negative. Alright, and remember the only thing that was positive up here was cosine. Alright, now if we're following around that circle, remember 180 was 6 pi over 6. So this right here is going to be 7 pi over 6. And this right here is going to be 8 pi over 6, or 4 pi over 3. And remember, it was 4 pi over 4 at 180, so this is 5 pi over 4 as it goes around the circle. Alright, now let's take a look at the fourth quadrant here. Hopefully you can start to assemble some of this on your own. From the center line, 30 degrees, 45 degrees, 60 degrees. So that makes this 300, makes this 330, makes this 315 degrees. As we're looking at the pi over 4s, if we look at how the pi over 4s have kind of gone around, I'm going to put a dot next to them. Let's put a purple dot next to them. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. That would make this one 7 pi over 4. Alright, and we look at the pi over 6, we have pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, or 5 pi over 3, and 11 pi over 6. Okay. Now their locations have to correspond. Now I want to show you something here. If you look at 3 pi over 2, 1/2, 3 pi over 2, 1/2, 3 pi over 2, 1/2, those are all the angles that are 30 degrees from the center. So this one right here is going to be 3 pi over 2, 1/2. This one's going to be 1/2. I'm sorry, not 3 pi over 2. Sorry. Square root of 3 over 2. This one's going to be 1/2 square root of 3 over 2. And these other two are going to be the square root of 2 over 2, square root of 2 over 2. Okay. Now over here, we know the only thing that's positive over here is cosine. Cosine's positive over here because that deals with the x's. Alright, so let's see what we have. All of them are positive here. just sine is positive here because that deals with the y. Tangents are positive down here, and cosine's positive here. A smart trig class, that's how I remember that. A smart trig class knows a smart trig class A S T C. That's how I remember which one's positive in which category. So as I look at that one down here, the cosines were positive, but the sines in there had to be negative. Alright, that's the unit circle. I hope you could follow along and fill that in with me. I'm sure we'll spend a lot more time with it.